Okay, I like that. Okay. So now, tell me what you notice about these first two terms. They're both divisible by 2. They're different terms. They're both positive. Red ink. They both have an x, right? So if we're trying to factor, we're looking for the GCF. Greatest common factor. So in these two terms, what is the greatest common factor? 2. 2 what? 2x. Isn't the greatest common factor 2x? So now, is factoring the same as dividing? Because we already divided, right? We already divided, but is factoring the same as dividing? No and yes. Okay? It's kind of dividing. We divided something specific into another polynomial and got a specific answer out, right? Factoring is we're taking the whole polynomial and dividing it into its pieces. But we're not starting with one particular piece, really, kind of, ish. Okay? So factoring is kind of like dividing, but it doesn't look like dividing. There's not a bar, like a division bar. There's not really a dividend or a divisor, things like that. We're just breaking it up into its pieces. Okay? 4x squared. If I divide 4x squared by 2x, what am I left with? 2x, right? And you could check that in your head by saying, okay, what is 2x times 2x? Well, 4x squared. Okay, that's what it was, so that's good. What happens if I divide this term by 2x? 3, right? Because if I divide it by an x, that x is gone, right? I could check it. What's 2x times 3? 6x. And then I'm done. Because all I'm looking for is the greatest common factor right now. You okay with that? What's the greatest common factor in these two terms? 3. If I divide a 3 out, what am I left with? Minus, x minus 4. Can you do anything else right now? No, because first of all, you don't really know anything else to do, right? But that's okay. What about this last one? Greatest common factor. 2y squared. So here's what's confusing if I say it wrong. If I say it wrong, it'll be confusing. If I say it right, it'll be fine. My greatest common factor is going to be the smallest one of the y's. Does that make sense? I can't take a y to the third out because this one doesn't have a y to the third. It only has a y to the second, right? So the greatest one is going to be whatever one of these is smallest. You okay? So what's left if I divide this term by 2y squared? 3y. And what about this? Minus 4. You okay so far? All right. Then we need to go here. This has a name. This type of factoring has a name, and I want us to see if we can come up with it. What kind of sign do you see in between the two terms? A negative or a subtraction sign, right? What's another word for that? Minus, what else? Difference. It's a difference of what? What am I subtracting here? What do these two terms have in common? What are they both? They're both terms. I agree with that. There's something special about them, though. What did you say? That's true, but not quite what I'm looking for. Not quite. You're on the right track. There's something special about both of these numbers. I'll give you this. There's something special about these two numbers too. They can both be square rooted, right? What's the square root of x squared? What's the square root of 16? What's the square root of 9x squared? 3x. What's the square root of 64? 8. Okay? So what do you think these numbers are called? If they can be square rooted, what kind of numbers are they? Squares. They're called the squares. Okay? So if we're taking the difference of squares, and if we're asked to factor the difference of squares, guys, that's cake. Ah, dang. I said cake and I don't have any cake. Sorry. It's easy. Here's how you factor the difference of squares. 2 binomials. A term here, a term here, a term here, a term here. That's how you know it's a binomial, right? 2 terms. 2 binomials. What's the square root of the first term? X. It goes at the beginning of each of the binomials. What's the square root of the last one? 4. It goes at the end of each of the binomials. Which one's your favorite, plus or minus? I can't decide either, so let's have one of each. Now, at first that seems like a trick, doesn't it? Okay? If I say factor, we're done. I want to show you why it's true, why it works. Okay? What if we multiplied this back out? This is not part of the factoring. This is part of our checking our work. If I multiplied this back out, I would get x squared minus 4x plus 4x minus 16. What happens with these two terms? It's 0, isn't it? What is x squared minus 6? Oh, that's our problem. So this is not part of the work. This is part of the checking. This right here is the answer if I say factor this. You okay with that? What about this one? Is it the difference of squares? We kind of already answered that question a minute ago when we were talking about square rooting, right? Okay, but I'm going to get 2 binomials. What goes in the front of each one of them? 3x. What goes in the back of each one of them? 8. And what kind of signs do we have? Okay, watch. I'm going to throw a wrench in things. Here I put the plus first and then the minus. Here I put the minus first and then the plus. Yeah, that's the correct reaction. So it doesn't matter, does it? Because it doesn't matter what order we multiply in. This could say 3x plus 8 and 3x minus 8. Aren't those two the same thing? Isn't this answer the same as that answer? Yeah, don't get thrown off by that. You okay? Now this one. You know I got to try to trick you, right? Is this the difference of squares? No, it's not. But what do you notice about these two terms? They're both divisible by 2. So what if I factor out a 2 to start with? Like the GCF problems I did a minute ago. What do I have left when I divide each term by 2? X squared minus 25. Aha! Is this the difference of squares? Then go one more step. What is it? X plus 5, x minus 5. You know you got 2 binomials. I just didn't draw them and draw the lines for you this time. We still have the same thinking process though, don't we? You okay with that? Hold on just a second. What you got? Nope. Got to have both of them. Okay. Yes, ma'am. What'd you say? What, on this one? Okay, so I said, is it the difference of squares? And you guys said no. Because I can't take the square root of 2. I mean, I can, but it would be a really ugly decimal. Not that I'm trying to judge the decimal and say that it's ugly, but you know what I'm saying. I can't take the square root of 2. It's not a whole number. But I did notice that both of these two terms were divisible by 2. So if I factor it out of 2, I get x squared minus 25. And I notice that is the difference of squares. X squared is a squared, 25 is a squared. So I give myself two binomials. The square root of the first term goes in the front of each. The square root of the last term goes in the back of each. And I give myself opposite signs. Okay? Does that help? Awesome. Can you put 2 and then x plus or minus 5? No, why not? That's a shortcut we can't take here. Okay? I need all of my factors written out. So it's got to look like that. Not like this. This is bad. See? There's a frowny face. Okay? Questions? Easy or hard? Okay. This one's even easier. What is it? This one was called the difference of squares because I'm subtracting two numbers that are squares. This one is called the sum of squares. I'm not sure why I dotted my U. I didn't mean to. Sum of squares. I notice it's adding. I notice these are both squared. You ready? Okay, done. I said, done. Sum of squares cannot be factored. If something cannot be factored, what is it called? Do you remember? If it can only be divided by 1 in itself, it is. It's prime. It cannot be factored. Remember how we checked these? Like I multiplied it out? There's not two factors that I can write down that would give me this as my answer. If I made these both positive, wouldn't I have like a plus 8x here? And if I made them both negative, wouldn't I have a minus 8x here? I'd have a middle term. This doesn't have a middle term. There's nothing I can put down that'll make this multiply back together to give me x squared plus 36. So it's prime. What about this one? Is it the sum of squares? What's the square root of 16? 4. X squared is x, right? What's the square root of 144? 12. Is it the sum of squares? Yes. Then what do I write as my answer? Prime. Done. You okay? What's this one? Difference? It's not the difference of squares, is it? X cubed is not a square. What is it? It's a difference of cubes. Remember, a cube is what times what times what equals that number. They all have to be the same, right? So what times what equals x cubed? What? X, right? What times what equals 27? 3, right? Okay, so when you factor the difference of cubes, there's this really pretty formula that I could remember if I thought about it and wrote it down for you. I don't know the formula. I know the pattern. If you want me to teach you the formula, I'll teach you the formula. I'd rather teach you the pattern. What do you want? Pattern. Binomial, trinomial. So difference of squares, I get two binomials. Difference of cubes, which kind of makes people think of 3 sometimes, right? I'm going to get a binomial and a trinomial that has 3. First, I'm going to fill in my binomial. What is the cube root of x cubed? X. What is the cube root of 27? 3. I'm ignoring signs right now. Okay? I'm ignoring signs. I fill in my trinomial from my binomial. You ready? Square the first term. X squared. Multiply these two together. 3x. Square the second term. 9. Don't worry, we'll do another one. The binomial I get from the cube root and the cube root. You okay with that? The trinomial I get from the binomial. square the first term, multiply the first and the second term, square the second term. Now let's know the signs. What's the sign in the problem? Then that's the sign in the binomial. The next sign is a plus because it's opposite of that one. Okay? So the first sign is what is in the problem. The next sign is opposite of that. So in this case it's a plus. And the last sign is always a plus. Always. Now, could I check this problem? How? I can multiply it all out, right? We don't really have time to do that. I'll do it for you tomorrow if we have time. But can you trust me on this one? If I multiplied this all out, I would end up with x cubed minus 27. Okay? So can we do this one? What do I get? A binomial and a trinomial. What goes in the binomial? A y and a 2. Tell me how you get the first term in the trinomial. Square the first term in the binomial. Y squared. How do you get the middle term in the trinomial? Multiply these two together. 2y. How do you get the last term in the trinomial? Square the last one. Now let's talk about the signs. What's the sign in the problem? Minus, so the binomial is a minus. The next sign is opposite of that. The last sign, always plus. Easy or hard? Okay, if that's easy, this one's even easier. What's this one? Sum of cubes. Now, here's the difference. These can be factored. But here's the good news. You already know how to do it. Because of how I taught you how to do these, you already know how to do these. What kind of terms do you get as its factors? A binomial and a trinomial. What goes in the binomial? X and 5. What goes in the trinomial? X squared, 5x, and 25. What are my signs? What's the sign in the problem? Then it goes here. What's the next sign? Opposite of that. And what's the last sign? Always plus. See? It's just a pattern. Do you want me to draw the formula for you? No? Okay. I mean, I will, or you could go look it up. It's in your book. Okay? Okay, so here's how it gets hard. Is this really hard, or are they just bigger numbers? Just bigger numbers. Guess what you get? A binomial and trinomial. Well, it goes in the first term of the binomial. 5y. And the second term? 6. I'll help you out. So what goes in the first term of the trinomial? Close. Square this whole thing. 25y, right? What goes in the middle term? 30. Uh-oh, I messed up. What did I do? 25y squared. Thank you. Okay, so this is 30y, and what goes at the end? 36. Square the first. First times the second. Square the last. You good? What are the signs? Plus, negative, plus. Same as the problem. Opposite of that, always plus. Good with that? How many terms are there? 4. When there's 4 terms, we're going to factor by grouping. Okay? When there's 4 terms, we're going to factor by grouping. Here's what we're going to do. Let's ignore the last 2 terms. Just completely ignore them. Like they didn't call us last night like they were supposed to. What's the greatest common factor in the first 2 terms? x squared, right? So if I factor an x squared from each term, what's left? X plus 5, right? Now we're going to just ignore the first two terms. What's common in the second two terms? 10, right? They're both divisible by 10. So if I factor out a 10, what's left? X plus 5. Now look at the two terms that I have left. I have this term and I have this term. Do those two terms have something common? An x plus 5, right? I did that on purpose. What happens if I don't get these two as the same? I stop. I'm done. Or I could not be right, right? What do these two terms have in common? An x plus 5. If I factor an x plus 5 from this term, what's left? X squared. If I factor an x plus 5 out of this term, what's left? 10. Done. I will do another example for you. Ignore the first two terms. What do they both have in common? The greatest common factor. X squared. What's left if I factor out an x squared? X minus 4. Now ignore the first two terms and just look at the last two terms. What do they have in common? A 3. What's left when I factor out a 3? X minus 4. Do those two terms have something in common? If I factor in an x minus 4 from this term, what's left? X squared. If I factor out an x minus 4 from this term, what's left? Done. Did that help? Okay. One more. This is trying to trick you. I'm warning you ahead of time. You ready? Are you ready? Okay. Ignore the last two terms. Just look at the first two terms. What's common? X squared. What's left? X minus 2. Now, you know and I know that I'm ignoring the first two terms, but I'm going to look at the last two terms. What do they both have in common? A 25, right? But what do I know has to be in the parentheses? I know I have to have an x minus 2, and if I factor out a 25, I'm going to get negative x plus 2. So what should I factor out? A negative 25. Does that make sense? To three of you? Excellent. Okay. What's left? X minus 2. Now, do both of these terms have something in common? What is it? Factor out an x minus 2. What's left from this term? Except I'm not done. Not this time. Does anyone notice anything about one of my factors? Yeah, this one is the difference of squares, isn't it? I have to go one more step. I have to break it down. That stays itself. I haven't messed with that at all. What does this one become? X plus 5 and x minus 5. Now am I done? Yeah. That's the lesson. That's the first day of factoring. My second favorite F word. Next to fractions. You know that. Any questions?